So children, today in magnetism lesson, please mute your audience. Children, in magnetism lesson, today we'll discuss lines of force. What is line of force? Children, actually, this you are going to draw in your lab also, children. How you will draw a line of force means you will take a white sheet, children, chart, and you will put a magnet here. You will put a magnet, and you will take a compass. Wherever compass head is north pole, tail is south pole. Wherever compass north pole is showing the direction, there you will put all dots, children. And after putting all dots, you will join all dots. It will come somewhere like this, children, like this, so you'll be getting like this, like this, like this, you'll be getting, children. Okay, children. So, how to define a line of force? How to define a line of force? Line of force is defined as line along which a freely suspended north pole tends to move is called line of force. Try to understand, children. What is line of force means? When I was telling how to draw a line of force, what did I say, children? Wherever north pole is showing, put their dot. Wherever north pole is showing, put their dot. Wherever north pole is showing, put their dot. I told you, children. So these joining of these lines only will give you line of force. So children, line along which a freely suspended north pole tends to move is called line of force. Please keep writing, children. I will not put any videos again, your wish. Line along which a freely suspended north pole tends to move, along which a north pole is going, along which north pole is going, that will take as a line of force, children. So line along which a freely suspended north pole tends to move is called line of force. So children, there are certain properties. Children, definition is 1 mark. And what are the properties of lines of force? Very, very important question. What are properties of lines of force? Children, what are the properties of lines of force means? First property. Children, if you take a magnet, children, if you take a magnet, outside they move from north to south. First property. Outside magnet, they move from north to south. Outside the magnet, they move from north to south. Outside the magnet, they go from north to south. And children, inside magnet, they move from south to north. So children, inside the magnet, they move from south. Outside, they go from north to south, and inside, they go from south to north. Children, compulsory arrow is important. North to south, you have to put arrow. And children, they are closed and curved lines, children. They are closed and curved lines. Children, all of them are, they are closed. You can see the line of force, children's line is closed and they are also curved, children. They are curved and they are closed. The lines of force are, they are closed and they are curved, children. And next one, if you see, they are crowded at poles. They are crowded at poles. Please note down, children, all of you. Why? Children, if you draw lines of force, children, if you draw lines of force, they will be like this somewhat. Lines of force will be like what? Like this somewhat. But at the poles, if you see, they will be crowded. So many lines of force will be present. Here at the poles, so many lines of force will be present. Why? Because poles are comparatively stronger. Poles are stronger than the middle of the magnet. Poles are comparatively stronger than the middle of the magnet. Poles are comparatively stronger than the middle of the magnet. That's why they are crowded at poles. Okay, children, they are crowded at poles. And children, they are crowded at poles. Next one. Okay, remember, children, lines of force, they are going like this, no, children. They will go parallelly. They will go, but no two lines will intersect. One line will not intersect other line. Try to understand, children. They will be touching. They will be going like this, but they will never cross each other. Very, very important. Last point. Two lines of force will never intersect. Two lines of force will never intersect. Try to understand, children. Two lines of force, they will not intersect like this. Two lines of force will never intersect because if they intersect, very important, so many times in board exam they ask, if they intersect, because children, if they intersect, what does it mean? Field is in two directions. Children, try to understand. If they intersect, field is in what field? Magnetic field is in two directions. If they intersect, field is in two directions, which is not possible. Which is not possible. Very, very important conclusion, children. This is okay, children. Lines of force will go like this, children, but they won't cross each other, because if they cross each other at one point, field is like this also and like this also, which is not possible. At a point, field will be in one direction only, children. At a given point, field will be in one direction only. At a given point, field will be in one direction, either this or that, but it cannot be at both directions. So no two lines of force will never intersect each other. Very, very important. Please mute your audios. Two lines of force will never intersect. Two lines of force will never intersect, because if they intersect, field is in two directions, which is not possible. If they intersect, field is in two directions, which is not possible. So definition is the line along which a field is suspended north pole tends to move. Line along which a field is suspended north pole tends to move. Outside they move from north to south. Inside they move from south to north, and they are closed and curved, and they are crowded at poles. No two lines will ever intersect. No two lines will ever intersect. Remember, children, no two lines will ever intersect. Why? If they intersect, field is in two directions, which is not possible. And last one more we are going to add, children. We are going to add one more. I'm going to add one more, children. Children, so this is line of force. Try to understand. This is line of force. Please try to understand. This is line of force. The tangent at any point on the line of force. The tangent at any point on the line of force gives the direction of magnetic field at that point. See, children, this is line of force. If you draw a tangent, this point, magnetic field is in this direction. If I draw tangent here, this point, magnetic field is in this direction. If I draw tangent here, this point, magnetic field is in this direction. So what you will say, tangent at any point on magnetic field, tangent at any point on line of force, tangent at any point on line of force, tangent at any point on line of force gives direction of magnetic field, gives direction of magnetic field, gives direction of magnetic field at that point. Try to understand, children. So tangent at any point, tangent at any point gives the direction of magnetic field at that point. Tangent at any point gives the direction of magnetic field at that point. So children, on line of force, if ever you draw tangent, at that point magnetic field is in this direction. If you draw a tangent, it indicates direction of magnetic field. Tangent on line of force indicates direction of magnetic field. Tangent on line of force indicates direction of magnetic field. So definition and six properties. Definition and six properties, 3 marks question, very, very important, children. Okay, so very, very important. Please copy it on the notes, children. All these points and this definition and the 6 points are very, very important. If possible, for every point, for every property, draw one figure, children. If it is property, if it is possible, like from outside they move from north to south, means like this you show. Inside they move from south to north, means like this you try to show. And they are closed and curved lines, means like this you should, children. And they are crowded at poles, means like this you should, children. Like crowded at poles, and no two lines will ever intersect, you show. And what did I say, children? Last one, tangent at any point gives the direction of magnetic field. Tangent at any point gives the direction of magnetic field. This is definition. These are 6 points. Definition, 6 points. Very, very important about lines of force. So children, already I completed magnetic field, and today I completed lines of force also. In the next class, we will discuss some of the rules to know the direction of magnetic field and direction of reflection of compass, solenoid, AC, DC, motors, generators, difference between AC and DC current. In the future classes, we'll discuss, children. We'll try to complete as soon as possible. Thank you so much.